giving the overview of the method, I'm going to briefly show you how the algorithm is designed. And next time we'll do an example with some small data set and we will calculate these rules by hand. The original idea with this method was for market basket analysis. So it was primarily designed to work with transactions such as customer came and bought a bunch of groceries, and this transaction is recorded in a database, milk, eggs, cereal, bread. Next customer came and bought eggs and sugar. Next customer, or maybe the same customer, came on another day and brought milk, eggs, sugar, bread. Every time something is purchased, is recorded as a new transaction. So the problem is, given the database of these transactions, where in each transaction is a set of items. Here we had 1, 2, 3, 4. Now we have bread, milk, and sugar, and something else in the set. 5 groups of items that are frequently purchased together. So we are looking for frequent item sets. The reason we would want to look for that is because hopefully the grocery store can use this information to do something to their advantage. They can arrange the items that are frequently purchased together next to each other so that we buy more stuff, or away from each other so that we walk more through the store to buy more stuff. It can be used for promotions, for issuing coupons to customers, and just for anything that would increase the profits of the particular grocery store or whatever goal it is that they're trying to accomplish. For example, a promotion will be if a customer purchases 3-way calling, then we will offer them call waiting as well, because these are often purchased together, so customers will be likely to accept this offer based on what the other customers are doing. If the patient has high blood sugar level, then probably has diabetes, because most of our patients in our data set with high blood sugar have diabetes. So this could be used for extracting some trends or patterns from the data and drawing conclusions that could be used to take actions to our advantage. Once we find these frequent item sets, we will calculate for them support. The support, actually we need the support in order to determine whether they're frequent or not. And the support is just the cardinality of the set. The cardinality, remember, is how frequently, in this case it would be how frequently this item set occurs in our database. How frequently a particular transaction happens in the data. That will be the support of the item set. So every time we generate a new item set, we will count the number of times that it happened in the data and record this number. That will be the support for that set. We usually want to find item sets with high support. This means these are happening very often. A lot of people are buying these things together. For example, the set is just this, dairy. It has one element, dairy. How many times dairy happened in the database? Look over here. These are transactions 1, 2, 3, 4. How many times do we have dairy in this data set? 3. 1, 2, 3. Support of dairy is equal to 3. How about dairy and fruit together? Dairy and fruit together. We have dairy fruit 1 time, dairy fruit 2 times. So it is equal to 2. The user might say, give me the sets which have minimum support 3. If they don't, I'm not interested in them because they didn't have them frequently enough. So when the user says threshold is equal to 3, this means item sets which have support bigger than 3 are considered frequent. If they're not frequent, we will remove them from our analysis and continue without them. So I would like to show very quickly. So if some item set is not frequent, it will be removed. And let's say this one is not frequent. Its support is less than 3. We remove it. Not only we remove it, but any of its subsets also will get removed. Because if the most general set is not frequent enough, the less general ones produced out of it also are not frequent, so that whole purple part will be removed from the analysis, according to this algorithm. So the way this algorithm works, and we'll do an example of this next time. These are our transactions, 1, 2, 3, 4. These are the items in the transactions. And so that's the first set, ABC. Next one is AC, AD, BF. First thing we do, take sets of single items. These are called single item set. So we will take each item in a separate set and count the number of times that it occurred in the data. The first one is A. A happened 2 times, 1, 2. Support for A is 2. Next one is B. B happened 3 times, 1, 2, 3. Support for B is 3. C happened also 3 times, support is 3. D happened once, support is 1. E happened 3 times, support is 3. Now, the user said minimum support should be equal to 2 or the sets are not considered frequent. So if we look here, are these frequent or not? Are all of them frequent? This one is not frequent because it's equal to 1, that's less than 2, so it's cross it out. And all of these subsets, which means we will not use D to create any item sets of 2 or 3 elements. D will not be in any of these. We remove it, and any of the item sets underneath will remove it as well. Any of its subsets. So now what we do, the ones that are left, take them and create item sets of 2 items. So we'll take all the combinations of the ones that are left, which is A, B, C, and E. So take the first 2 together, A and B. Next, A and C together. Next, A and E together. Next, go B. Take all the combinations. B and C. B and E. And finally C and E. These are item sets of 2 items. For them, we'll do the same thing. Count the number of times they occurred in the data and write it down. This is their support for A and B is equal to 1. Is this set frequent? No. Cross it out. A, B, cross it out because it's equal to 1. So what we have left is this right here. We will continue to take all the combinations. So now from 2 item set, we'll go to a 3 item set. All combinations of these will be A, B, and C. A, C, and E. And B, C, and E. From both these, B, C, and E is the only one that meets the threshold. And now we cannot combine anymore because we only have 1 left. But if there are more than 1, we continue combining them until there's only 1 left, or until there's none left because they don't meet the threshold, and we remove them. And then we're done with this algorithm. So we have produced the frequent item sets. From these frequent item sets, we can generate association rules, and I will show you how to do this next time.